Hi all, today I will present about our group project which is crypto programming project and we are from group 3 section 1. I would like to introduce our group members. First is Pang Webi, the second is Navin Kumar and third is myself Magdalene and the last one is Siti Fatima. For introduction, cryptography secures communication and protects sensitive information from unauthorized access. This project explores three methods, which is vigilance cipher, binary shift, and message flipping. These methods add layers of encryption, ensuring confidentiality and integrity. By demonstrating their practical application, this project highlights the significance of cryptography in modern data security.
My name is Pang Wei Bin, metric number AN200195. I would like to present for the encryption and decryption system flowchart for this project. So for the encryption flowchart, we will firstly input for the original text, then for the regional key for the regional cipher encryption, then for the shift values for the right shift. The shift value will be represented by alphabet S. So when s is greater than 0, which means the values will be shift to the right, the result will be displayed for the original cipher text and the flipped text, and finally is the right shift value result, which is the final encrypted result for the encryption. So if s is not greater than 0 or is a negative value, the result will showing an error text, and then the system will be go to the end. While for the decryption part for this project, firstly we will like to input the encrypted text with the purpose for the decryption, and next we will input for the general key for the general cipher, and then we will input the shift values for the left shift, which is represented by the alphabet S. Since this is the left shift for the shift values, so the shift values will be less than 0. So when the shift value s is less than 0, it will finally showing the decrypted result, and will the system will be end. If not, the result will be displayed for the error text, and finally the program will be ended with the displaying of the error. That's all from me. Thank you.
Good evening. My name is Navin Kumar Selvam. My matrix number is CN200109. So today I'm going to explain apart from our project, which is programming. So we have two different type of programming. One is for encryption, and another one is for decryption of our data. So, to understand our coding, we have to first understand that we use three type of algorithm to encrypt and decrypt our data. So, the first algorithm is a beginner algorithm, and the second one is flipping algorithm, and the third one is right shift algorithm. So, from here, first we will start from encrypted algorithm. So, first we can see that the first part of the coding is to define the beginner algorithm. The first step is to define the Wegener algorithm. So this code over here shows that the for example, this the first one, we have to convert the uppercase, and then we have to all this is the code to define a Wegener code. And the second step is the code is flipped in reverse order, like flipping algorithm. So for example, my name is Naven, then it's flipped into from last to the first, which is n is it's upside down, yes. And the third algorithm code is provided here, which is right shift algorithm. So in this case, the code will ask us, for example, from the beginner algorithm, we have to put a key. From the key, the beginner, for the first step is it asks for the key, and then it then converts it to the key. And similarly to the right shift algorithm, the code will ask us for the number of shift, and then we can apply a number, and then the output will be, um, it will print the text of the beginner algorithm, and we have to apply the key, and we have to apply the number of shift. So from here, the code can understand the key and the number of shift and the text that we have to convert. And the output will be, it will print the beginner result, which is the output from the beginner, and the output from the flipping, and the output, the overall output after all the encrypted code we can get at the end of the result. Yes, actually we know we can put only one output, which is the encrypted result, but to ensure that we can see the step by step process, we have put three types of output, so we can see the changes of each code. So the second one is the decrypted code. So similarly with the encrypted code, decrypted code is just uh, vice versa of the encrypted. Same steps. So for example, firstly it will ask for the key which we use for encryption of data, and the same key will be asked, and the same beginner process code is over here. And then just now we reverse the code, now we have to reverse again to get the actual form, the code is over here. And then for example, the same, just now we shift to right shift, now we have to shift to left in order to get the result. So similarly, like encrypted, it will ask for the text, and it will ask for the key, and it will ask for the number of shift. In this case it's left shift. And the output of the beginner algorithm and the output of the flipping, all will be appeared over here. Hi, for the next part I will explain the encryption result. So as we can see that first of all, the code will ask to enter the text to be encrypted, which is the data. So in this case we have put data security is hard, and the key is BNF. So the shift value we have to put ourselves, which is for this example we put 3, and the beginning result is this, and flipping result is this code, and the final encrypted result is this code. And the next is the decryption result. As for the decryption result, we can see the code from the encryption over here is then placed over here, and we can put the key, and we put the number of shift. For the shift it will go for left at this side. So, and we can see the decrypted text is same as the encrypted. So I will show the example over here. Okay, for I have load my Python code for the security data is over here. So for example, enter text to be encrypted. So for the text, we can just put any text that we want. This one is protect data testing encryption. We put enter, and then the key we can put same, we can put my name Naveen, and right shift we can put 2 for instance, and we have the encrypted result. So this is the encrypted code, so which then I can copy it, and I will place, and this is the decrypted Python code I have put, and I can place it. And if I place, it will ask for the key, and I can put the key just now, which is my name Naveen, and then the left shift, which is 2. So if I put, we can get the same decrypted result, which is project addressing encryption, which is over here. This the text just now I put over here, project data, with this encryption code is then applied here, and we get the same. So that is for result from my side. Thank you.
Now I am going to be presenting about the discussion of our projects. During the implementation of this project, we were able to familiarize ourselves with cryptography, especially with Vigenère cipher algorithm and right binary shift algorithm. Vigenère cipher is chosen as one of our algorithms in this project because it provides a level of security that is suitable for many everyday use cases. It uses a Fourier alphabetic substitution method, which means that each letter in the plaintext can be encrypted using different shifts, making it harder to break the cipher through frequency analysis. Besides that, the Vigenère cipher is relatively easy to understand and implement. It involves using a keyword or key phrases to determine the shift value for each letter in plaintext. As for the right binary shift, the reason this algorithm is chosen is because it is not typically used as a standalone encryption algorithm. It can be component of a more complex cryptographic algorithms. One of the reasons this algorithm is chosen in our project is because it is used to manipulate the bits of the message. By manipulating the bit, cryptographic algorithm can achieve different transformation of operation that contribute to overall security of the system. Next is the conclusion. In conclusion, from this project, we are able to build a program that are able to encrypt and decrypt a message. Based on the project, we can say that Vigenère cipher and the right binary shift algorithm are two distinct components within the field of cryptography that serve different purposes and offer unique advantages. Both the Vigenère cipher and right binary shift algorithm have their place within the broader realm of cryptography. The Vigenère cipher offers simplicity and versatility, making it suitable for basic encryption needs, whereas the right binary shift algorithm contributes to the manipulation and transformation of data in more complex cryptographic algorithms. That's all from us. Thank you.